So I want to review number 1 real quick. The reciprocal of sine is cosecant, which means I flip it. The reciprocal of cosine is secant, which means I flip it. Take the reciprocal. The reciprocal of tangent is cotangent. Flip it. Okay, so let's go to the next one. I see I have 21, 28, and I have to find the hypotenuse. The great thing is I see that they both divide by 7. So that's a 3. Divide by 7. 4. That means blue 5. So that means that my actual length of my hypotenuse, I'd have to multiply by 5, is 35. Okay? But I'm going to use the blue simplification. So sine of theta, cosine theta, tangent of theta. Start with the 3 basic ones I'm more familiar with. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, or as some of you know, it's just sine over cosine. Now, the inverse of sine, cosecant, flip it. The inverse of cosine, secant, flip it. The inverse of tangent, cotangent, flip it. Okay? Let's go to the third one now. Now, the third one, there's a couple issues. First issue is it's simplified all the way. Second issue is it's not a Pythagorean triple. So I'm going to have to do the quadratic formula to find that third value. Now, since this is the hypotenuse, I have to go 1 squared plus x squared equals 4 squared. 1 plus x squared equals 16. X squared equals 15. Square root, square root. This length is rad 15. Okay? Now, remember, when you're doing the notes, I encourage you to start it and see if you can handle it, and then let's go. So sine theta. And by the way, you don't have to start with sine theta. It's just what I start with. Cosine theta, tan theta. Okay. Sine is, now remember, if you're stuck, it might be helpful to go opposite, adjacent, hypotenuse. If that helps you, I encourage you to do it. So sine is opposite over hypotenuse. I can't actually do anything, and I can't tree it, so sine is good. Cosine is adjacent over hypotenuse, and 1/4 is still 1/4. And tangent is opposite over adjacent. Now, this one isn't going to be good because you can simplify, so this should really be just rad 15. So I have sine, I have cosine, I have tan. Now, remember, the inverse of sine is cosecant. Oops. So that means I have to flip that. But remember, I can't have a radical in the denominator, multiply it by itself. So cosecant of theta, let me put this down here, is actually 4 rad 15 over 15. Cosine. Cosine, oops, I realized I did cosine incorrectly. I'm sorry. It's, no, actually we're good. Is 1 over 4. Well, if you flip 1 over 4, it's 4 over 1, and 4 over 1 is just 4. So secant of theta is 4. And then tangent, if you flip it, would be cotangent, which is 1 over rad 15. Can't have a radical in the denominator. So it's really rad 15 over 15. And let me point out, you don't have to show this work. If you can go straight to the answer, I encourage it. Okay? So I need to get ahead. So turning the page, you already did this in class today. Turning the page, you already did this in class today. So now we're going to address angles of rotation. Now, this is going to seem like a simple concept, but this simple concept is going to be used for way more complex ideas, so you need to really make sure you're getting the game, okay? So when you start, if you look, you start at 0 degrees. You're always going to start here, and you're going to rotate this way to make a circle, okay? This is called the initial side. Let me zoom that in because that's where you're starting. So if you see you have 0 degrees, and then when you get to here, you're at 90. And then when you keep going, you get to 180. And then you keep going, you get to 270. And you keep going, and technically you're at 360 also. okay, because a circle is 360 degrees. That's positive rotation, okay? But if you go a negative rotation, instead of going the positive way, you're going to go the opposite way. So negative 45 degrees, so that's negative 90, negative 180, negative 270, negative 360. So let's start. I'm going to want you to write the angle in standard position, and then I want you to tell me, actually let's just do that for right now, standard position. So that means you draw this. If it helps in the beginning, you might want to do this just for your own sanity to get used to it. Now if I'm going 210 degrees, that means I'm going past 90, past 180, and then 210 is about here. We're guesstimating. So from the origin, you draw a line, and then you're going to go like this and show that you started here and got to here, and it's 210 degrees. And that's the answer. Okay? Now the problem with number 2, let's start the same. 0, 90, 180, 270, 360. You don't have to write it, but you've got to get that down. That's got to be so comfortable to you. The problem is that 1020 is going to be going around, because that's only 360. And then if I go around, it's still not going to be enough. So options are you could go like this, but you're going to notice it's going to get ugly. I go around 360. I go around again, another 360, that's 720. And then if I go around again, then I'm at 720, that's another 300, which gets me here. That's not what I want to see. It looks like a snail shell. So what I would prefer you doing is making it look like this. So what you're really doing is you're taking away one of the rotations, and then you're going to end up with 0, 6, 7, nope, did I do that right? 760, nope, 660, okay? But then I see I have to go around again, so I'm going to take away another 360, and I'm at 300. Now that I'm at less than 360, I would rather you draw it like this. So 0, 90, 180, 270, 360. So I'm at 300 degrees. So I go over here, boom, and I'll do that in pink, starting at the initial side. And then I will show that this is actually 300 degrees, which is equivalent to 1020. So don't give me this. It's just too messy. Let's go to the next one. The problem is this time, instead of going the positive way, it's going the negative way. Two options. I'm one of those people that I don't like living in a negative world, so I like making things positive, which means I want to find a positive equivalent. Now, if I'm going negative 300 degrees, what I'm really doing is doing the opposite of 360. So what I would rather do, and don't memorize this or it won't make sense, you have to understand it. I would rather do this and tell you that negative 300 degrees is like positive 60 degrees. And the way I can equate it is like if you think about a clock. Oh, that's not a clock. A clock where you have 12, 3, 6, 9. And if I said negative 3, you would go this way, negative 3. But really, negative 3 is the same thing as positive 9 o'clock. And I would rather live in a positive world than a negative world. And with that being said, I need you to always show me the positive equivalent if you get a negative. So if you look, 60 degrees is between 0 and 90. Fake it. Fine with me. And then your answer is 60 degrees. Live in a positive world. If you notice, negative 300 degrees, negative 40, negative 90, negative 180, negative 270, boom, it ends up there. All right, negative 135. I don't like living in a negative world. So I'm going to add 360. And when I do that, I get 225. Okay. So when I draw this, I'm at 0, 90, 180, 270 is too big. So it's about here. So I'll show my work. Noticing this time I didn't put the 0, 90, 180, 270, 360. You don't have to. But if it helps you, you can. And the value is 225 degrees. If I went the negative way, then what I'd be doing is going negative 90, but negative 180 is too far, so it's right here. If you look, this matches that. All right, that's standard position. Let's go to the next page. Coterminal, okay? Coterminal, what I'm asking for is another angle that's negative. So if I give you a positive, the negative is what I want. If you look back here on this previous page, we technically already found the coterminal. The coterminal of negative 300 is positive 60 degrees. The coterminal of negative 135 is positive 225. And if you notice, that 360 was what we needed. So the coterminal of this means we're going to subtract 360. So in my calculator, I'm going to go 360 minus 88. My coterminal is negative 270 degrees. I just want to give you a visual. If you went 88 degrees, that's to here, because that's 90. But if you went negative 272, that's like 0, negative 90, negative 180, negative 270. It's a little bit more. Boom, it ends you right there. So you're showing that these two angles are exactly equivalent, positive, negative. All right. Now the problem with, okay, let's go to number 3. Negative 120, this time we're going to add 360. And when we add 360, we get 240 degrees. That is my coterminal. Make sure you understand the vocabulary word when I say it, okay? Now, number 2 is a little bit different because the problem is it's more than 360 degrees. So I have to make it less than 360 degrees. So now I have a positive angle of 140. And then my coterminal of that, which is, by the way, equivalent to 500, because what you're doing is this. 500 degrees, 360, and then you're going another 140. But that's ugly, so the equivalent is 140. So the coterminal of this, subtract 360, and when you subtract 360, it's negative 220 degrees. So the coterminal of 500 degrees, which is really 140, is negative 220. Next one, same issue. Subtract 360. When I subtract 360, I get 65 degrees. This is equivalent to that. The coterminal means you subtract 360, which is negative 295 degrees. Whether you graph this or this or this, they will be the exact same thing in standard position. Okay, reference angle. I'm highlighting this, man. I'm highlighting that because reference angle is the most difficult for people. So actually, I'm going to pause it and I'll do it in the next video.